Hey everybody, my name is Marco, and in this video, I'm going to teach you how to get this whole Microbot working. So I'm working off these assumptions that you know how to code in Python, you have this whole Microbot assembled, and you've sort of uh, played around with the Microbit board, right? So there is this other board. So this is the Microbit, right? Hopefully you've had some experience with it. So this is the Motobit. This is the board that talks to the motors, right? And then these are the motors. So I'm gonna try to teach you how to do this all in one video. Hopefully I can do this in under an hour. Let's see how this goes. So first, I'm gonna hop over here to Visual Studio. So just have your Visual Studio open, and in the description there's a folder called Microbot. Just download that and then have it somewhere on your computer. So we're going to be using that. That folder contains uh, this stuff in here. So all these files. So I already have mine under my recents, but you would have to like go to File and then Open, right? And then just go wherever it is. So I have mine under my GitHub folder, Microbot, and Open. And so now you should get something like this. If you click on the folder or the Explorer button, you see all your folders here. And so this right here, this is like it's a really nice version of Markdown, but I'm assuming you don't have this app, so I'm just trying to get Markdown working for this. Right, so we can have this instead, and we can still get a good reading. And so for that, we'd go under extensions, and let's type down Markdown. So you can download this Markdown all-in-one by this person. So download that. Markdown Preview Enhance by this person. So go ahead and download that. Also, please, if you haven't watched the previous video, because I go into how to program the Microbit, so make sure you have Python downloaded and you have this downloaded right here. So make sure you have this downloaded. So I don't have it enabled, so I'll have it enabled for this. And so now if I, let's say, okay, so it's working. Okay, let's go back to this. Oh. So once you have those Markdown extensions downloaded, you're gonna have two icons. Click on the leftmost. It says Markdown Preview Enhance instead of just Preview. This one's way better. Click that, and then you'd have this. And then if you want, you can close this down, and then click Explore. And so I'm just going to run through this, try to explain the basics, and then we'll get started into doing some coding, and then we'll actually see the robot in action. It'll fail at the beginning, but we're going to tweak it a little bit, and then by the end of this video, you're going to have your robot being able to move forward, backwards, left, right, be able to turn counterclockwise and clockwise and whatnot. Just your imagination is the limit. So here for a brief introduction to robotics. So just an overview, robotics is the intersection of multiple engineering fields. In my opinion, it's the pinnacle of robotics engineering is the Boston Dynamics Atlas robot. This robot's only possible with the collaboration of multiple engineering disciplines. All right, so here you can see this is the complete Atlas robot. I'm sure you guys have seen videos of this robot like doing backflips and front flips and jumping over boxes. If you haven't, just Google Atlas parkour or something, and there's a pretty amazing videos. And so you can see when it comes to this robot, they have like a bunch of cabling, cable management. There's a bunch of motors and actuators, and then this whole thing is like I think it's an engine just to give the robot all this power, and then plus there's a computer on it, right? So there's mechanical engineering here where they have to design this frame. Um, Here you can see this is a motor. So there's electrical engineers making sure that the motors work to support all this load of the robot being upside down. And then there's computer engineers making sure that everything's talking to each other, all the motors, um, the sensors. It's a huge undertaking. So looking at the figures above, uh, you can see, like, as I was listing off, mechanical, electrical, and software. And we're gonna sort of do the same thing with this Microbot. So here we can see sort of the mechanical is like the chassis, and the electrical would be the actual Motobit board, and this is how the components would look like for the Motobit. And then this is just an outline or skeleton code that I've written so far, just to make this process easier. I'll elaborate on the software a bit later, but it's going to look like this. And actually, there's already a file with all this code in the Microbit or Microbot folder. And so these are all the components. Just, by the time you watch this video, hopefully you have it all assembled. If you go on their website, they make it really easy to do. This is the Microbit. This is like the brains of our robot. And then you can sort of think of it. This is like the nervous system. This is what does all the talking. The brain. This does all the thinking. This does all the talking with the different sensors and motors. And then here's the motors. It's like you're actually, your arms or your legs, but for the robot. And so we're not going to delve into the sensors, right? So I have this whole other section when it comes to the infrared sensors. I'm not going to focus on this video. We're just going to focus on getting the motors to work, and we could actually get the robot to move the way we want it to. And so, the small difficulty with this robot is there isn't like a pre-built function where it's just like robot move or robot drive, right? We're going to have to make our own our function to do that. But here are some general constants that we're going to deal with. So it works with I2C, which is just sort of like a communication method between computers. I'll just leave it at that. I don't want to make it too abstract. But the motor sort of interprets a value from 0 to 255. So that's a range of 256. And so when you feed it the number 0, it's going to go reverse at 100% speed. And then when you feed it a value of around 63.5, it's going to go reverse but at 50% speed. And then when you feed it a value either 127 or 128, it's just going to stand still. Like it's not going to move. And then as you keep moving up, it starts going in the forward direction. So 191.5, it goes forward. And then to go forward at max speed is 255. And so here you can see that I put round because the Motobit, which is the nervous system, it only accepts integers. And so mathematically, these are the actual 50% values, right? But the Motobit won't accept a float or something with a decimal. All right, so just to make this easy on ourselves, we want to do some number mapping. So I'm going to cut real quick to a video of me doing a number mapping example. All right, so here I'm going to start doing some number mapping. And so number mapping is basically shifting values between one number system to another number system. And so let's just start off by writing number mapping. Right, and so I'm gonna visualize this in two ways. I'll try to get uh, this point across as clearly as I can to you guys. Right, so right here, let's just imagine this is negative 100, and let's imagine this and that. That's 0, and then this is 100. And then we have another number system. And it'll be something like this. 0, 127, 128, and 255. Right? And so remember, the robot accepts values from 0 to 255, but we want to feed it values in something that we can comprehend. So our input being negative 100 up to positive 100. And so you can imagine these values are getting mapped like that. So that's visually, that's what's sort of happening. These value negative 100 is getting moved up to 0, and then 0 is moving up to 127, 128, and then 100 is moving up to 255. And so I guess a better way of illustrating this is using an actual coordinate, a two-dimensional coordinate system. So if I draw coordinate system right here, negative 100. Right, so we make our x-axis our input, and then our y-axis is going to be our output. Right, and so we know that at negative 100 on our input is going to be 0 on our output. So we can have a point right there. And then we also know that at positive 100, we have a point at 255. So we could have this point up here. And so if we get a ruler, right, if I draw, we're going to get a nice line like that. Okay, so now the issue being is, okay, so now the issue is we want to find that equation. But there's sort of a simple equation that we know. Y equals mx plus b. And then here are the values we do know. We know negative 100 and 0. And then another point that we do know is we know 100 is 255. Right? And then based on those values, we can figure out m and b. And so let's plug in negative 100 and 0. So negative 100 being our x and y being 0. And so here we can get 0 is equal to negative 100 m plus b. And so we can do some math, and we can get b is equal to 100 m. And the next point. So that's a simplification that we have now. Now let's plug in the next point into the same equation. And so we get 255 is equal to 100 m plus b. And then we already know what b is, right, from the previous equation. And so we can plug in b into the new one. So then we can get 255 is equal to 100 m plus 100m. Do some more math. 255 is equal to 200 m. M is equal to 255 all over 200. Also simplifies to 127.5 over 100. M is equal to, you can move the decimal place 2 times. And you can get 1.275. And then we can plug that into B. And so B is equal to 100. And we can use the previous form, 127.5 over 100. B is equal to 127.5. And so we get y is equal to 1.275 x plus 127.5. Right. 1.275 x plus 127.5. But in practical terms, once we start coding, remember we're going to get some float numbers. So it's actually going to be y effective is going to be round y. And then we know that this point right here is 127.5. All right. So now that we have these equations, we're going to cut back to Visual Studio Code and actually code these equations. All right. So we're here back in Visual Studio Code. So here I have a file called numbermapping.py opened up. And so this is just a file where we can sort of practice making that number mapping equation work with what we're trying to do code-wise. So here I've sort of given you like skeleton code. So at the top there's a short description sort of to demonstrate how all this is going to work. I've imported math module just in case if we need it. And then here, this is the this mapping function that we have. So it takes 2 inputs, input 1, input 2, and then here I've sort of outlined what this function will do, which is basically what I discussed in the drawing. But here's the caveat: we want it to return an index list of 2 integers based on these 2 inputs. And so if I run this right now, so I'm going to do Command Shift P, and I'm going to do Python run Python file in terminal. And so if that doesn't pop up, I would just write terminal, and then you'd probably see something that'll run. Something towards the top. If not, you can press the green play button. Right, so I can run that. And so I already ran this previously, but here it sort of shows you how the round function works. So round function examples, so round 0.4 is 0, 0.5, 0, and once you actually reach 0.6, you go to 1. And so here it outlines some examples. So right now we inputted 0 and 0. We're supposed to get either 127 or 128, but we get 0. Same thing, inputs of 100, supposed to get 255, but we get 100. And so we're sort of trying to work, make this function work for all these test cases right here. And so let's start with the equation we did have. So right here, I'm just going to write it as a comment. Y equals, and the equation was 1.275 times x plus 127.5. All right, so a good way of thinking about this is we're dealing with an input, um, we're dealing with this numbers variable, which is going to be a list of inputs 1 and 2. And sort of we're going to basically apply this equation to input 1 and input 2. And so let's do those actions within a for loop just to make it easy. And so here we do for I. So I just like using I. And we can do it within a range. Should put in first and take off cap locks. Oops. So in range. So if you want, you can do 2, or you can do length of numbers, whatever floats your boat. Do that. And so here we have to return numbers, but once numbers has been sort of modified. And so the way I would go about it would be numbers and then make it a, so we're going to do numbers index the first index of numbers. So we do numbers I, or square brackets I, and then remember we have to round this. So we do round, and then we can do numbers I times 1.275 plus 127.5. And then just to make sure that this works, 100, or just in case, like, because sometimes, stuff can happen. So we're just gonna have fail safes here just to make sure that we don't get any errors that we don't expect. So I'm gonna add, if whatever comes out of this is less than 0, just make sure that it becomes 0. And then I'm going to do the same thing for the upper limit. So if we get numbers I, plural, is greater than 255, we'd get numbers, square brackets, I is equal to 255. And then let's save it. And then let's see what we get. So I'm going to do Control Shift P and run it. And so now we get input 0, 0, expected output either 127 or 128, output 128, input 100, 100, output's 255, input negative 100, output's 0. Here, negative 50, we get 64 on our expected and our actual. Positive 50, 191 on our expected and actual. And then we get the flipped in reverse. Positive 50, 91, 191 on the expected, and then the negative 50, positive 64. So this is basically how we would go about it. Remember, this is just to make sure our code works. This isn't really necessary, but it's always like nice to have that in your code. Just like if worse comes to worse, this will fix whatever goes wrong in this equation. And yeah, so this is basically it. So you can, sort of take this as a working example of what we're going to have to do in the actual Microbot file. And so, okay, so let's have this opened up so I can explain what's going on. And so actually, I just noticed this. Let's add sleep. Yeah, okay. So, okay, we'll leave it as this. And so here I've created a class. So here class, and I've called it Microbit, and here it initializes the Microbit hardware. And then here we have some constants. So remember I told you we do I2C stuff? So this is sort of constants we need for I2C. And these weird numbers where you get 0x20, 0x21, those are called hexadecimals. And so basically all that means is like it's a it's a different way of representing numbers. And so here, if you get 0x59, that's the same as 89. X70 is the same as 112. X21 is 33. X20 is 32. It's just when you do I2C stuff, you communicate in hexadecimals. It's something I don't really want to get into, but just accept it that these are just the same thing, but just written in a weird way. All right, and so when you do class, you always need the init method, and so here we're just gonna pass it for now, just for now. We'll come back to it later. And here we have an enable method, and so this is all what this is going to do is just going to tell the robot, oh, okay, your motors are on, right? Or like have your motors be ready to accept commands. And so here, we're writing stuff to the address, and then here we're sort of encapsulating a certain constant, which is the command enable, and then we give it like x1 is the same as 1. So this is sort of like a way to say true. So enable true, enable, right? And so disable is sort of the enable command, and then just give it a 0, which is a false. So this is sort of what's going on. This is sort of like out of the depth of this class, sort of take it as is. This is where the interesting stuff happens. We're gonna have to do the same code that we did for the for this equation, but sort of do it here. And at the end, we're going to write to command speed left and command speed right, which is already constants here, and we're gonna make it speeds 0 and speeds 1. And since we already wrote this code, right? So let's copy that and paste it there. Okay, so right now, numbers isn't working too well. So what we can do is, double tap it, and we can do, so if you go to, I think it would be edit. So if you go to edit, there will be a replace. Right, and so we can copy numbers, put it numbers, and so it finds 7. So if you keep pressing enter, it's going to cycle through all the numbers, right? And then we'll just replace it with speeds. And then if you press enter a bunch of times, it's going to replace them one by one. And then until you get no result. And then press escape, and you're all done. And then here, we get a little squiggly line because it didn't copy correctly. So we're going to shift that over. We're going to indent it. And so the way I do indent is let's see if there's a so I usually do command and then right bracket because you don't really want to do a tab because I guess you could do tab. You can do tab or command right bracket. If you're Windows, I think it'd be control right bracket or tab. right? Because in Python, indentation is really important. All right, and so that's about it, right? Hypothetically, this should work. This should work. Okay, let's see if I'm missing anything. Well, I told you guys, uh, this should work, but you're going to see uh, something that'll occur. Um, and so, all right, so now all of our class is done. And so now we actually have to code it. So towards the bottom, right? So this is, right, this Microbit stuff is, like, this is sort of all of our class information. This doesn't really actually do anything. This is sort of like stuff that our robot can look for. Now we actually have to code it. So I already started code. So once your robot's flashed, the first thing it's going to do, it's going to show a happy face. It's going to clear it, but it's going to show it for 2 seconds or 2,000 milliseconds. And so in order to do the motor stuff, we have to initialize it. So I'll do moto equals to motobit and leave it as that. So remember when we initialize it, there aren't any arguments that we're passing through. And so now we have to do moto.enable, right? And then enable doesn't really have anything. And then we do moto.drive, and let's make it let's make it 2020. Yeah, let's leave it at that. And then actually, so another thing, so that your robot doesn't really crash into the wall, we're going to do sleep. So sleep, it's sort of basically, its input is milliseconds. So if I do 500, 500 would be the equivalent of half a second. So we'll do sleep for 1,000, which is just 1 second. And then we'll do moto.drive, and we'll do 0, 0. Okay, so theoretically, this will enable our car, our robot. It's going to go forward at 20% speed. It's going to do that for a second, and then it's going to stop driving. Actually, I'm gonna change it to 1.5 seconds. All right, so yeah, feel free, flash this. I'm going to flash it and then cut to a video of the robot doing what this code does, and then I'll point out what goes wrong. All right, so uh, hopefully you got it working, and you probably got 2 things on your mind. Uh, it moved. You're probably excited that you actually see the robot doing something. But the other thought in your mind is, wow, that was pathetic. Or why did it, turn clockwise? Um, and so the reason for the robot turning clockwise instead of straight is the motors are sort of, you can imagine the left one was going the correct direction, right? That would explain the counter or the clockwise direction, right? You'd have the left one going forward. I'll try to do this with my mouse. And then the right one going back. And so it's just because the motors are flipped once you assemble it. And so we can uh, fix that 2 ways. Either flip the polarity of the cables of the right motor. So you know how it tells you to plug in red cable at this spot, black cable at this spot. All you can do is just flip them around, plug them and then switch the colors around. Or we can do it code wise. And I think it's pretty cool. And let's do it with the code. And so now we can get creative and actually edit the init method. And so here I would do invert left is equal to false, and then I'll do invert right is equal to false. And then we'll make a list, because the list is going to be constant, and actually I'll make it a tuple. So they're not changing. Once we initialize it, they don't change. So we'll do invert left and invert right. Alright, so now we have it set like that. And then now we can scroll down into our drive method. And all we have to do is under the for, because basically what we're doing is we're flipping the number around. So whatever is being fed in, so let's say it's right, that 20 value. If we whatever we're inverting, because we're going to invert the right motor, right? You can sort of already down here at the very bottom, we can do invert right is equal to true, right? And so here, it's going to cycle through these left and right. And basically, the tuple is left and right. And we want the right one to be true right here. And so all we have to do is right here is write if self dot invert square brackets I, we can do speed I is equal to negative speed square brackets I. And so that should fix, that will flip what we want. So basically what it's doing is, so right now speed left is just 20, and we didn't give it an initialization to invert the left. So it's going to run through, it's going to be 20, or it's going to do range, right? And then the invert of the first index is false. And so it's going to pick up false from up here. And so if false, right? So then it just skips over. It doesn't multiply the speed value by a negative value. And so basically it just runs through this round speeds first index, so it'd be 20 times 1.27 5 plus 127.5, and then it rounds that value. And then this is just the failsafe that I was talking about. And then it would go back to the for loop. It would go to the second index, so now it would be speed right. So if self.invert second index of invert, which we specified as true, so if true, speed's second index is going to be it's negative, so it's just flipping the sign. So 20 here is going to flip it to negative 20 here. And so now when it runs through this equation, it's going to be negative 20 times 1.275 plus 127.5. And then it rounds it, and then this is our failsafe. And then once that for loop is done, it's going to put the output of this equation, which is going to be some value over 127, and then the negative 20 is going to be some value under 127.5, right? And so this should fix the problem we have. All right, so now let's save, flash it, and then I'm going to cut to a clip of the robot. Hopefully. All right, so it worked. So now we got the robot actually moving forward the way we wanted to. I mean, it was moving slowly, but that's just because I put 20 for left and right speed. But you can, I mean, you can go ahead and go 100 full speed, but it's gonna crash into a wall or something. Uh, I wouldn't push it over 50, just to be safe, or so that your robot doesn't break, because that thing can go fast. Uh, but yeah, you can sort of experiment with it. So let's say instead of 20, make it 25. 25 faster, right? And then we can make it sleep for, make it go forward at a faster pace for 2 seconds. And then instead of stopping, we can sort of make it 35 and 20. And so now you can see that our left motor will go faster than our right motor. And so you can see now after 2 seconds of going straight, the robot would sort of turn, not really turn right, but it'll sort of curve to the right. And so you can sort of play around with these numbers and sort of make a increase the difference between them to make sharper turns, or more uh, curvier turns, right? Because if you make the difference really small, right, 35 and 30, you'll see the robot will sort of drift to the right little by little. But yeah, feel free to experiment with this. And yeah, if you have any questions, uh, drop them down in the comment section. Uh, I've added all the links to what you need for this in the description. And hopefully this was informative. And have fun playing around with the robot.